What's going on, Algebra 2 students? My name is Mr. Dalde. I'll be teaching you blah, 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 blah. I don't know. I'm not really good at my introductions besides my fact that I say what's going on. Anyway, let's start off with some ideas about this thing. Let's see what we can do. Let's see. All right. F of x, this is just kind of a warm-up, so if you don't have the packet written out, that's fine. Just start writing things down. Now, we have f of x equals x squared plus 6x plus 5. We can graph that using Desmos, and I have Desmos uploaded to all of your computers, so you guys should be able to just plug this in and graph it. But you know what? Let's graph this in our minds, because I think that would be really cool. Now, first question I'm going to ask you, though, is where are the zeros? And what the zeros mean is basically, it doesn't really matter what this, what the zeros mean when you're looking for the zeros is if the graph looks like this or the graph looks like that or whatever, the zeros are where does this thing cross the zero axis? Does that make sense to you? Do you guys understand how to do that? Or where does this thing cross the x-axis? Not the zero axis. What am I talking about? That doesn't make any sense. Cool? Alright. Now, another name for these zeros is called the x-intercepts. This is where it intercepts with the x-axis. Now, here's my question to you. How do I find the x-intercepts? Do you know? What's a way to find the x-intercepts? If you don't know, say IDK, but at least I know you can hear me. Say, I don't know, or I'm thinking. IDK from Lena. Keep going. I've got other people in the class, right? Alright, at least I know you guys are alive. IDK, good. Good, it's fine if you don't know. Just tell me something, like I know, I don't know. Alright, my question to you is how to find x-intercepts. Well, I'll tell you one thing. If it's an x-intercept, it crosses maybe here and here, or it could cross it to other different places. It doesn't really matter per se, but what my question is, there's something I can tell you for sure about this or about that point. If I were to give you the coordinates of that point, I would give you two numbers, right? Because whenever we're dealing with coordinates, we have two numbers. It's an ordered pair. What is the first number? Is I actually don't know. It looks like, give me a guess. What is the first number? Negative something, right? Throw out a guess. It's fine if you're wrong. Just want to make sure you guys are paying attention. Negative, yes. No, that doesn't make sense at all. What would the first number be? You guys can say anything as long as it's like -2, -10, -6. Perfect, that's great. -2, -6, -10, whatever, -1. But I like what Kyrina, I like what she said is basically 0. Now, it could be -2, 0. It could be -6, 0. It could be -1, 0, like Kyrina says. But here's the point: is no matter what this first number is, I know that the second number is going to be what? There, good. Everyone's answering. It's going to be 0 because that's the whole. That's the definition of the y-intercept. It has to be 0 over here. I actually am teaching class. Can you give me a second? I gotta figure out what this is, because maybe it might be super important. I'm not sure. Hello? Hello? Yes. Hi, Liana. Yeah, what class? Which class are you in? Which one? 1, 2? Okay, yeah, there's class at 10:30. All right, if can. Okay, sorry. Okay, bye. Sorry, guys, I was an Algebra 1 student. She was just asking about how to get into class and everything. I apologize. I probably shouldn't answer the phone while we're teaching, but let's do this anyway. Lena, are you having trouble hearing? Oh, no. I don't mean that sarcastically. I just hate tech issues. Can anyone else hear? You guys all having trouble hearing or what? Okay. Lena, then you might want to log out and log back in, because if other people can hear, that means the problem is on your side. And I just realized, can somebody type that to her, tell her to log out and log back in, because I don't have my keyboard on me. And I just realized that if I'm telling her the instructions and she can't hear, it doesn't really make much sense. Anyway, let's keep moving on. I know for a fact that if it's on this point right here, if it's anywhere on this line, then this second number is going to be 0. Like, it doesn't matter what that number is over here as long as that number is 0, because it's the x-intercept. So, the answer, how do you find the x-intercept? You set y equal to 0. Does that make sense to you? Because y represents the second number. Yes, no, maybe, I don't know. I'm confused. Awesome. Now, I have a question for you. Here's the next question. How do you find the y-intercept? How do you find the y-intercept? That's question number 2. You set x equal to 0 exactly. All right, so you guys understand that if you want to find the zeros, they're asking for the x-intercept, which means you set y equal to 0. You guys got it? All right. Now, they're asking for the zeros. We want to try to graph this thing without using a graphing calculator. So we want to be beast mode like that. So here's what we're going to be kind of taking a look at. We're going to graph this thing without using a graphing calculator. We want to find the zeros. So we're going to set y equal to 0. Now here's the problem. There is no y in this case. But I did tell you that this thing is actually a representation of y. So we just set that equal to 0. You got that? Now, I have a question. Do you guys know how to solve this? I'm not sure, actually. This is actually the first one on page 5. In section 5.1. I'm doing the first thing. This is review number 5. All right. Do you know how to solve this problem? If you don't know, say IDK, but at least answer something. Because I need to make sure that you guys can all hear me. So everyone needs to chime in. I don't remember, and it's fine. I'm not going to ridicule you. I'm not even going to remember who says I don't know. I just want to see that people are responding to me. I don't either. That's fine. Okay, all right. Let me show you how to do it. Okay? There's two different ways to do it. There's actually a few different ways. There's 3 different ways that I can think of. The first way is called factoring. The second way is called complete the square. And then the third way is called quadratic. There is a possibility that you've learned this and this inside of Algebra 1 class. However, I'm sure that you've learned this one. And I'm actually probably going to be reteaching you how to do these ones in Algebra 2 class. So now, but for now, I know that this thing can be solved. This is the easiest way. This is not as easy. This is actually kind of not that bad. I think as far as difficulty, I'll put it like maybe this would be 1 star, this would be 3 stars, this would be 2 stars. So this is the easiest one. Here's the second easiest way, and here's the kind of the hardest way, but it's not even that bad, really. Anyway, so when you factor, what you're going to want to do is put these guys into these little parentheses like this. Now, this parentheses kind of represents something that I'm going to multiply together You guys remember FOIL? The first with the first, and the outers with the outers, and the inner, and the last, that kind of stuff. When you multiply two parentheses, you got the first times the first, and the outer times the outer, and the inner times the inner, and the last times the last. Well, we're going to kind of do an unfoil. Basically, this is the answer that we got after we foiled it. What we wanted to know is what did it look like before we foiled it. So, what we're going to do is we're going to try plugging in some things inside of these parentheses and seeing if it works. So, I'm going to plug in an x here and an x here. And then I want two numbers. Is this vaguely familiar with you guys for Algebra 1? Say yes or no. Come on, help me out here. Vaguely familiar, kind of brushing off some cobwebs here. All right. I want two numbers that multiply out to be the number 6. Or no, I'm sorry. Multiply out to be the number 5. But when I add them, they come out to be the number 6. Can you think of those numbers? There we go. 1 and 5. Perfect. That wasn't even that bad. Now, if you FOIL this out... Okay, alright, wait a second. I just realized something, Corey. I'm going to lock this down for you guys so everyone sees my screen. Corey, is that better? Alright, did it fix it? Did I fix it? Got it. Awesome, awesome. So now what I'm saying here is when you multiply these out, when you FOIL this out, first times the outer times the inner times the last, I'll tell you what, why don't you guys try that at home, and while you're trying it at home, I'll do it over here. So the first times the first is x squared, the outer times the outer is 5x, inner times the inner is 1x, and the last times the last is 5. I can add the inners, because those are the same. This is the x squared, this is the 5x, that's 1x. So I've got x squared plus 6x plus 5. You guys remember how to FOIL, right? Okay, now bear in mind that this is just side work. Because I just wanted to make sure that this is correct. This is actually the answer I wanted. This I need to multiply out to make sure that this is the same as that. And it is, so we're good. In fact, if you give me a second, I'm going to erase the side work. That's all right with you. I just want to double, that was my double check. And it was just foiling it out. But anyway, do you know how to solve this at this point? Can you tell me what the x-intercepts are now? Because at this point, you can just take a look at it and read it off the equation. One and 5, close, but wrong. Here's the way to think about it. Okay? There we go, Kaylin. Exactly. -1 and -5. Think about it like this. Alright? Now let me go through the argument with you and then you guys can just read it. Basically, you take the negative of whatever is in here. So it's -1, -5. But the way you think about it is this. If you have something, some quantity, times another quantity, okay? And that equals 0, then you know one thing. Well, you know two things, really. You know that either this is equal to 0, or this is equal to 0. Correct? Because if the first one is equal to 0, it doesn't matter what the second one is, because the whole thing will just collapse down to 0. Similarly, if the second one is 0, then it doesn't matter what the first one is, because the whole thing just kind of down to 0. We cool with that? Alright, so what I can say is either x plus 1 equals 0 or x plus 5 equals 0. Now solving these algebraically is pretty easy. You just move the 1 to the next side, and that goes x equals -1, x equals -5, and that's how Kaylin was able to figure out that -1 and -5 was my answer. Boom. We happy? You guys satisfied? Alright, cool. So if I were to graph that, by the way, that means my zeros are at -1, 0 and -5, 0. I'm going to erase all this work down here. So take a picture or make sure you wrote it down. Now the picture button is just hold down the control key, and it's a little like window capture looking thing above the 6 button. Anyway, it should only take you like 3 seconds. So 3 seconds are up. I'm going to erase it. You guys gotta learn to take pictures quick. If not, you can watch this video archive and it'll be taken care of. That's where the zeros are. Let's figure out, let's see. We want to graph this thing. Actually, I should probably make this thing more like this. If we want to graph this thing, we know that the zeros are at -1 and -5. So it's 1, 2, 3, 1, 2, 3, 4, 5. So -1, -5. And we know that the parabola looks something like this. We don't know exactly, but we know the parabola looks something like that. Would you guys agree? It's probably going to look something like this. Maybe I'll just draw that. Alright. Now what we want to do is we want to find the vertex. Can you guys think of how to find the vertex? Actually, here, let me ask you this question. In order to find the vertex is obviously a point. It's got 2 numbers associated with it. One number and the second number. Because it has to have 2 numbers because it describes an x coordinate and a y coordinate. Agreed? Does that make sense to you? I mean, you can't complain about that. That makes sense, right? Alright, now, how could we figure out what that x coordinate is? Can you guys take a guess? Look at the graph and tell me what you think the x coordinate is. I think Kaylin's onto something already. She's already figured it out. Awesome. -3. Yeah, it's -3. I totally agree with you. It's x equals -3. Or at least I know that's the first number. Right? Because, how did you figure that out? Actually, Kaylin already put it up on the chat bar already. What you do is you say, all right, well, I know that the vertex of this parabola is going to be the x-coordinate of the vertex of the parabola, I know at least, is going to be in between these 2 points. So if I'm talking about -5 and -1, then what's exactly in the middle of -5 and -1? Well, all you would do is add up -5 and -1 and then divide by 2. You're taking the average. You guys remember how to take an average? You guys just add up 2 numbers and divide by the number of numbers you've divided or added. In this case, we're only dealing with 2 numbers, so you take the average of -5 and -1. So that would be -6 if you add them together. Divide that by 2 and you get -3. Voila. We cool? Does that make sense to you now? Awesome, awesome. So we figured out how to get -3. Can you figure out a way to get the y value? What is the second number? Because the vertex has 2 numbers. There we go, Kaylin. I was just going to ask, is there some place where we can go where if we plug in an x value, it would tell us what the y value is? Can you think of any place? Any place at all that might have that information? The equation, exactly. Now this equation tells us this is a function of x, and every x that you give me, I will give you what the y value is. You tell me what the x is, I'll give you what the y is. Now in this case, The x that we are looking at is 3, so we want to figure out what f of 3 is. So all we got to do is plug in 3 into here. Now, if we plug in 3 into here, we end up getting 3 squared, which is 9. Or, I'm sorry, wrong, close. We want to plug in negative 3. Correct? Because the negative 3, because I mean that's what we want to plug in. 3, I mean it would just be the wrong spot if we plug in positive 3. Alright, so we want to plug in negative 3. You guys can see what I'm doing? Okay. I hate to say it again, but you might have to log out and log back in because I'm not sure why you can't see what I'm doing. I have the whole window locked for you, so I don't think anyone can change the view from what everyone else is seeing. Anyway, the thing is in the way. What thing? What thing is in the... Oh, maybe the... Oh, I see. What if we try this? Is that better now? Click on the camera thing and it should pop up. Alright. Anyway, we want to plug in negative 3 into here, so let me see. Negative 3 squared is positive 9. Plus 6 times negative 3, which is negative 18. Plus 5. So adding that up, that's negative 5, or negative 9 plus 5, which is negative 4. So my vertex is located at negative 3, comma, negative 4, making my graph look like this. Let me erase what it probably looks like, and I'm going to tell you exactly what it looks like. Or at least I'll tell you information that helps you get exactly what it looks like. I know that my zeros are at negative 5 and negative 1. I know that the vertex is located at negative 3 and down 4. 1, 2, 3, 4. I have a parabola and it has to cross through these 3 points. The only parabola that can cross through those 3 points probably looks something like that. Now that is how you can graph a parabola without using a graphing calculator. I think that's pretty awesome. Because everything is awesome. Everything. Alright, I'm done. Are we cool? Now I'll give you a second to take a picture of that while I wait. I'm going to kind of do one of these. Alright, take a picture of your computer screen. Oh, I'm sorry, Sam. You're right. Actually, I was too busy drawing my mustache. Where did I get 9 minus 18 plus 5? Well, I plugged in negative 3 into here. Where did I get that negative 3? Well, I knew that that was the vertex, the x-coordinate of the vertex. So I wanted to figure out what the y-coordinate of that vertex was. Where did I get that negative 3? Well, I knew that it was in between negative 1 and negative 5. Where did I get that negative 5 and negative 1? Well, I figured out what the zeros were of this equation. That basically recaps what we did for the last half hour. Is that all right with you? Can we move on? Are we good? All right. Now, if you go over to Desmos Graphing Calculator, which is an app that's loaded up onto your computer, and you type this, x caret 2, and then you press the right arrow, plus 6x plus 5. The caret means to square it. And then you got to press the right arrow to get out of that line, because if you keep pressing plus, it will just keep going to the small exponent place. If you type this into your calculator, or to your computer, it will graph that exact graph for you, confirming that we knew what we were doing in the first place. I'm going to erase this. Alright. I'll tell you what, I'll do one more of these things, and I'm going to do it in about 2 minutes. I'm going to do it very quickly. Is that alright with you? maybe I should take a little bit longer to do this because this is kind of important. Do you guys, all right, before I start this, let me ask you this. Do you know about the quadratic equation? Actually, you know what? I'm going to stop. Oh, yeah. You guys know about the quadratic equation? If you don't, say no. If you do, say yes. Or at least you know about it, but you don't necessarily remember how to use it. Okay. Let me do this for you. I'm going to write a few things down, and I'm just going to keep them at the side. ax squared plus bx plus c equals 0 yields x equals negative b plus or minus the square root b squared minus 4ac all over 2a. This is the quadratic equation, and I'm not a big fan as a teacher of pulling equations out of my butt and throwing it up on the board and saying memorize these, and I haven't done that. I'm just showing you that once upon a time you probably were shown this equation. When you were shown that equation, you probably were shown how it came to be. If you weren't, then I'm going to make it my mission in life to make sure that you understand that this equation is not magic. But for now, we might need to use that. And I'm realizing that they probably didn't have, or they didn't build it up like the way I would have wanted them to do it. But anyway, they're just asking you to use it. So for now, this is how we're going to do this. I'll show you how to use this equation in this next problem. Okay? I've got f of x equals x squared plus 8x plus 15. Are we cool with that? You guys like that? Now, I told you, all right, we want to find the zeros. I know how to spell. All right, when you find the zeros, you're actually asking where are the x-intercepts. When I want to find the x-intercepts, what do I do? If you don't know, scroll to the very top of the chat bar and look, because we just talked about this. If you want to find the x-intercepts, what do? You can look at your notes, because it's in your notes. Like 5 lines ago, 10 lines ago. Plug in 0 for f of x exactly. We set the y equal to 0. If you want to find the x-intercept, the y equals 0. If you want to find the y-intercept, the x equals 0. So it kind of, if you want to find the zeros of an axis, you set the other variable to 0. So I'm going to set this thing equal to 0. So I have 0 equals x squared plus 8x plus 15. Now, I told you that there's this trick. This is called factoring trick. So I go x and an x. Now I want two numbers, come up for me with two numbers that multiply out to be the number 15 and add up to be the number 8. Three and 5, 5 and 3. You know what? Why the heck did they tell me that these quadratic functions do not factor? Both of these factor perfectly. I don't understand what these guys are off their rocker. I don't understand. Yes, I agree with you. 3 and 5, 5 and 3. I don't understand. Maybe I made a mistake somewhere, but I'm looking at this problem, and it looks to me like that's a perfectly fine answer because 3 times 5 multiply out to be 15, and when you add them together, they make 8. Or you can go 5 and 3. It doesn't really matter. I mean, they're both going to yield the same answer. Are we cool with that? So let's say, Mr. Quadratic Equation, I'm going to put you in my pocket, and I'm going to use you a little bit later. But for now, I can just go with straight-up factoring. All right? Now, once we have it in this form, can you tell me what the answer is? Negative 5 and negative 3. Exactly. X equals negative 5. 3, x equals negative 5. Perfect. Because you set this thing equal to 0, x plus 3 equals 0, x plus 5 equals 0, and you solve, and you just get, all right? Is anyone confused about how I did that? Or really how Melanie did that. No, okay. All right. So my zeros are at -3, -5. Actually, you know what? Not -3, -5. It's at -3, 0 and -5, 0. Those are the 2 points. I'm going to erase this part. Take a picture. 3, 2, 1, erasing. All right. Now, what I want to do is I want to figure out what my vertex is. Can you guys tell me what the first number is? What is the first number going to be? -4, exactly, because -4 is exactly between -3 and -5. Then I plug in a -4 into here, which is kind of what Sam was asking last time. And this is how we were able to get that equation. You plug in -4 into here, so f of -4 is equal to -4 squared plus 8 times -4 plus 15. And Sam, that's where we got that other equation that you were a little confused about. But anyway, we just plugged in -3 in the other case into the equation. We plug in -4 this time. So that would be 16 plus 8 minus, or 8 times -4, 8, 16, 32, -32 plus 15. So what is that? That's 3, -3. Did I do that math right? I'm not a human calculator. I'm good at math, just not good at like arithmetic. You guys got it? -1. You're right. You're right. I'm sorry. You're right. Perfect. Yeah, -1. All right. So the vertex is at -4, -1. If I want to graph that, then can I erase this? 3, 2, 1. Take a picture. Okay. If I were to graph that, then I would graph at -3, 1, 2, 3, or 3, -5, and my vertex is at -4, -1, so down here. So I have a parabola that has to cross between these 3 points. That must be the parabola. You guys like it? You guys understand it? We cool? Awesome. Now, we're going to get into something that's particularly radical. That was kind of a joke. Because what we will be covering right now is this thing called radicals. And these are called complex numbers. And really, it's a terrible name because they're not really that complex, but I don't know, whatever. This is kind of important stuff, especially when we're starting to hit the quadratic equation. So, what I want to show you guys how to do is figure out a little bit about complex numbers. For example, what is the square root of 25? Do you guys remember the square root? What it's asking is what times what will give me 25? The answer is 5. We're cool with that? So, the square root of 25 is equal to 5. What is the square root of 24? What's the square root of 24? $4.7. Sam, did you use a calculator for that? Did you guess? All right. No, you know what? I love your guess. That was awesome. It's an awesome guess. Good job. Someone use a calculator. Confirm whether or not Sam got close. I actually think it's closer to 20, like maybe 4.8, 4.9 even, 4.85. There we go, 4.8. Awesome. Now, see, the thing is, it's hard to get the square root of 24. Like, we can get the square root of really good numbers, like, for example, the square root of 4, or the square root of 9, or the square root of 25, the square root of 16. All of these are really nice. These ones aren't as nice because you'll need a calculator for that, right? But how can we make this thing simpler? By the way, I listed a bunch of numbers. I'm going to write those numbers down at the top. 4, 9, 16, 25. It's a special set of numbers. Can you guys think of what the next number is? 50? Nope. I'm a unicorn. All right, yeah. 36, exactly. Good job, Savannah. What's the next number? 49, exactly. Very good. These numbers are called the perfect squares. It's because it's nice to take square roots of these. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. 6 times 6 is equal to 36. 7 times 7 equals 49, and so on and so forth. Now, is 24 listed in these numbers up here? The answer is no. No, 24 is not in here. But we can make this a little bit simpler. Not completely simpler, but a little bit simpler. By pulling out some of those perfect numbers. For example, 4 goes into 24. So the square root of 24 is really the square root of 4 times 6. Agreed? Now the square root of 4 times 6 is really the square root of 4 times the square root of 6. Agreed? And the square root of 4 is just 2. So that's called simplifying the radical, or simplifying a complex number. You're just pulling out these types of numbers out of these, a little bit more confusing numbers. What's the square root of 6? Well, that would be something you would have to look up. I'm not saying you could get the answer exactly, but it would be something you would have to look up. Actually, you know what? Type in your calculator, what is the square root of 6? Tell me, write it down. I don't have a calculator on me. 2.44. All right, so we got 2 times 2.44. Multiply those two together. You get 4.88. Hey, isn't that really close to what the answer actually is? In fact, up to like 2 significant figures, that's absolutely correct. Wait, where'd you get 1.4? 1.14? What's going on? No, you're supposed to multiply them together, not divide, I think. Okay. Alright, so I'm going to erase this. Actually, I'm going to erase all of this. We cool? Alright. Oh, I see. Now they want to teach you guys complex numbers. Got it. Alright. So, here's the next part that we're going to do. What if we have something a little bit more What if we have something a little bit tougher? For example, what is the square root of -9? What's the square root of -9? 3? 3? Okay, all of you guys are saying 3. Some of you guys are saying -3 because of the 9 there, right? And Kaylin's refusing to answer. But actually, Kaylin's correct in this case. Because what I'm asking you is, what times itself is equal to -9? Now, if I multiply 3 times 3, I'll get 9. If I multiply -3 times -3, I'll get 9. So there is no number. Okay, fine. What if I multiply -3 times +3? Oh, okay, then I'll get -9. Right? I'm like, wait, isn't that an answer? My answer is no. My question that I ask is, what times itself is equal to -9? Now, -3 times +3, those aren't itself. That's not the same. You're not multiplying the same thing together. You're multiplying two different numbers together to make -9. So we have this thing that we throw in there that we call an I. All right? Now, what an I is, and we just, all it is, well, I is the letter I. It's just, it's a line with a dot on top, the one that you guys learned when you guys were like 4. What the I is, it represents, for us, the square root of -1. And we call these imaginary numbers. Now, I think that's also a terrible name for imaginary numbers, because a lot of people ask me all the time, well, why? Actually, you know what? Ask me my favorite question. What is my favorite question of all times? You guys remember? How do you look so handsome? Good one. All right, you're getting bonus points after class for that one. All right. My favorite question is, why should I care? What is the point? Why are you teaching me about negative square roots? Because it doesn't really, like, when am I going to use this? I am going to be a fashion designer, Mr. Balde. I will never use negative square roots. Right? Like, or I'm going to be an electrician. Even an electrician doesn't use negative square roots. And I'll admit to you, there might not be a time when you directly use negative square roots. Unless, of course, you're an electrician. Then you're going to be dealing with this stuff, actually. What's amazing in math is I'm trying to teach you the history of how to think correctly, logic. And in teaching you the history, I need to come and teach you this, one of the most pivotal things that we've discovered is this imaginary number, this concept of imaginary numbers. But it rears its head in a few places, and I think it's rad. It's a crazy idea. Maybe what I'll do is I'll show you a demonstration. If you guys ever see a telephone pole? Of course you've seen telephone poles. And there's the lines that connect them like that. Can you guys understand what I'm saying? All right. If a bird lands on this telephone pole, it will start, that wire will start to swing back and forth like that, in and out. But what will happen eventually is actually this wire will start to swing. Even though no birds are landing on that wire, both of them will start to swing. And I think that's crazy. And the only way to explain that is this thing called resonance. And that resonance has to do with that value right there. Anyway, for now, what you just need to know is I is equal to -1. So when we factor this -9 is actually the square root of -1 times 9. We know that so really that's equal to the square root of -1 times the square root of positive 9. You guys agree with me? This right here is defined as I, so you just write an I there. The square root of 9 is just 3. So the answer is 3I. Are we cool with that? Alright, now I wanted to get through all of this entire packet. There were 16 pages and I'm on page 2. It took me an hour so far. And I know that we probably should be going with teaching really quickly. But why don't I take about 5 more minutes? I'm going to go through this example problem and then I need a break. It's hot in this office. I'm tired. So let's do this example problem. Let's skip this example problem too. I think that you get this. Actually, you know what? You know what I'm going to do is I'm going to do one of your homework problems for you because I'm that nice of a guy. All right. Let's do number 13 on page 3. I'm just going to take out one of these guys out. All right, ready? Actually, you know what? Let's do an even harder one. Let's go -1/2 minus the square root of 28/4. Okay? All right. So, first thing I'm going to do is I'm going to combine fractions. This is number 14. I'm going to combine fractions. So I've got -2/4 minus the square root of 28/4. You guys understand how I did it? Yes or no? Do you understand why I did it? What I did here? All right, Lena, all I did was I multiplied this fraction, the top and the bottom, by the number 2. So 2 times 1 is 2, and 2 times 2 is 4. Now, that's how I did it. The reason why I did it, or what I did to it, or the reasoning behind that, is because I wanted to make these denominators the same. When I add fractions or subtract fractions, I need a common denominator exactly, Caleb. So I need to make that bottom one 4. So in order to make that bottom one 4, I have to multiply that one by 2, but then you have to play fair, so you got to multiply the top by 2. Are we cool now? So now when I have a common denominator, I can just put that over the same denominator. -2 times the square root of 28/4. That's good. Now, the square root of 28, I can divide 28 by the number 4, right? So that would be what, 4 times 7, I think. Are we cool with that? And then what I can do is I can just make this -2 times minus 2 times the square root of 7 over 4. You guys like that? Now, one of the things I can do at this point is, since there is a factor of 2 in every term over here, this is one term, this is one term, this is one term, I can divide everything by 2. You got to be very careful with these tricks, and if you do this wrong in your homework, I'm going to burn you on it, only because I want you to learn how to do this really well. Divide that by 2, divide that by 2, divide that by 2. This becomes -1 minus the square root of 7 all over 2. That's the answer. All right, you guys, what do you say for a 5-minute break? Let's make it like an 8-minute break. We'll go up to 10 o'clock. Sound good? Okay. Welcome back, folks. Just wanted to make sure that you guys are all here. Can you hear me okay? Can you hear the words that are coming out of my mouth? Okay, good. Awesome. Can you see my face? Can you see with your eyes? Can you see the image that this handsome body is projecting? Awesome. Good. We're going to do this one. We're going to try this one. You ready? We're going to try factoring x squared minus x minus 1 equals 0. We're going to see what we can do with that. All right, let's try it. You guys ready? X, and what we want to try to do here is we want to figure out two numbers that multiply to be the number 1, negative 1, but add to be the number negative 1. Can you think of those two? They need to multiply together to be negative 1. And then when you add them together, they need to be negative 1. One and negative 1. Let's try that. I think that's a great guess. Let's take a look. Let's FOIL that. X times x, that's x squared. Outers is negative x. Inners is positive x. Last is negative 1. So this gives me x squared, negative x plus x. That cancels each other out. So that becomes 0 minus 1. So I have x squared minus 1. I'm sorry, Kaylin, that doesn't work. I want it to look exactly the same, and it doesn't look exactly the same. But that was a good guess. Kaylin, in fact, just the thing about it, I can't think of any other guess that you would have. Because what other numbers multiply to be the number negative 1? And the answer is there's none. There are no other numbers. I mean, maybe you can do negative 1 and positive 1, but that won't change your answer. That still won't work. So we're trying to solve the zeros of this equation, but the problem is factoring is broken. It's breakdown. It doesn't work. In fact, we can't factor that. So now we have to turn to this thing called the quadratic equation. All right? Now, one of the things I hate, I really hate doing, and I'm almost debating of whether or not I should follow exactly this curriculum or deviate a little bit from it. But I think I'm going to follow exactly this. I'm just going to kind of go where they take me. Have you ever heard the term complete the square? You don't need to remember exactly how to do it. I just want to remember. I want to know whether you've heard that term before. Completing the square. I got a yes and a no. If the majority says yes, then we're going to go. Oh no. Alright, then I know that what we're going to spend on. Alright, so I've got 3 no's. I would have assumed that some of you would have said yes. It's an Algebra 1 thing. And if not, I got to call up your Algebra 1 teacher and beat him up. What grade are you guys? You guys are in Algebra 2 now? Who did you take Algebra 1 from? Was that Mr. Loving? That was 2 years ago, right? Huh. Yeah, but you should have learned completing the square. That was probably like at the last end of the stuff. Anyway, you know what? Don't tell me about your Algebra 1 teacher. I'm not here to talk bad about any of the other teachers. I actually think the other teachers at the school are great. Let's solve this problem. And I'm going to actually, instead of teaching you the quadratic equation, That's where I want to arrive. That's where I want to finish. I have a half hour to try to teach this to you. So I'm going to do less asking you questions and more of just straight showing you. Now what I need you to do is, since I'm not pausing and saying, do you understand? Do you want to get it? Are we cool? I need you guys to stop me anytime you guys are confused. Is that all right? Can you do that? Say yes or no. I need you to say, I'm confused. Wait, how did you do that? That kind of stuff, because I'm not going to do it. I'm going to go into straight up lecture mode. All right. So what I'm going to do right now is I'm going to show you completing the square. And I'm going to show you this trick I use. All right? Now, there's this trick. What I'm going to do is I'm going to write this equation down, x squared minus 1x minus 1 equals 0. And all I did was I rewrote this equation, but I just put a big space in between. Now what I'm going to do, and this thing might really confuse you, but just trust me for now, is I'm going to add 1/4. You can ask me where I got that 1/4 from, and I'll tell you. But before I do that, I cannot just go about adding 1/4 to the left side of an equation. That doesn't follow the rules of being an equation. An equation is equal on both sides. So I can do this. I can add 1/4. I can add whatever number I choose, as long as I subtract that same amount as well, because really what I'm doing then is I'm just adding 0. And I can add as much 0 as I want. It won't change anything. All right? Now the question is, where did you get the 1/4? Well, I took this number, divided it by 2, and then squared it. Negative 1 divided by 2 is 1/2, or negative 1/2. Squared is 1/4. Now, where did I come up with that procedure? Well, that's the trick. All right? Now, here's the nice thing. You see these first 3 numbers? The x squared minus 1x plus 1/2. That can actually be factored nicely. It can be factored as x minus, or I'm sorry, that's supposed to be 4. 1/2 minus 1/2. If you don't believe me, I'll prove it to you. I'll FOIL this. So this is kind of, this right here is just side work. And this will be side work over here. If you don't believe me, I'll prove this is the same as that. Foiling that, that comes x squared. The outers is negative 1/2 x. The inners is also negative 1/2 x. And the last is positive 1/4. When you add negative 1/2 plus negative 1/2, you get negative 1. I'm going to stop and ask this question. Do you believe me that these are the same now? I'm not trying to trick you, I'm just asking. All I did was I FOILed this out. Alright. But this right here is only these first 3 terms. So I still need that last part, so that would be minus 1 1/4. Or see the negative 1 and the negative 1/4, that's these last 2 terms. That's this part, which is the negative minus 1 1/4. Or maybe 5/4. Are we cool with that? Alright. And then that's still equal to 0. I didn't really change anything in the equation. So really, I've played by all the rules here. I haven't done anything outside of your laws of mathematics. All I did was I added this crazy 1/4 term. but I subtracted it at the same time, so I didn't really change that equation. The trick is, where did I get the 1/4 term? But I mean, we came up with that trick. We figured that one out. So now what I'm going to do is, all right, this thing right here, if it's this thing times itself, really it's just x minus 1/2 squared minus 5/4 equals 0. I want to solve for x, so I've got x minus 1/2 squared equals 5/4. Very cool? All right, now, when I take, I'm going to have to take the square root of both sides to get rid of that square. So I have x minus 1/2 equals the square root of 5 divided by the square root of 4. I know what the square root of 4 is. The square root of 4 is 2. I can just rewrite that as 2. But before that, I'm going to just take this 1/2 over to the other side by adding it. My answer is x equals 1/2 plus the square root of 5 over 2. By the way, I forgot to do this. I need to add in a plus or minus over here. Do you understand where the plus or minus comes from? Maybe I should have gone back and explained that to you too as well. Do you understand? Because I need you to answer. I need you guys to answer. Do you understand where the plus or minus comes from? Okay, I'll tell you, okay? The plus or minus, here's where that comes from. I'm going to ask a separate question. X squared equals 9. X squared equals 9. What is x? Well, x equals what? If x squared equals 9, what is x? 3. All right, everyone answer. Everyone answer. X squared equals 9. What is x? 3. 3. Because 3 times 3 is 9, right? If x squared, if I plug in 3 in here, 3 times 3 squared is 9. All right, all of you are half correct. All of you are wrong. Because this works as well. Negative 3 times negative 3 is also positive 9. Right? So, you need to account for both the plus and the minus. That's why we have the plus or minus. And that arises whenever you find yourself in the situation where you have to take the square root of both sides. You need to make sure you add in that plus or minus to account for both the positive and the negative version of those answers. Does this make sense to you now? That's why when I took the square root of both sides over here, I threw in that plus or minus over here. Okay, so are we cool with completing the square? You don't necessarily understand what the motivation for it is, but at least you've seen it. Fair? At least you've seen it once in your life. I mean, I just did it for you, so at least I know you've seen it. You should have seen it in Algebra 1. I'm kind of disappointed that you didn't. I'm not disappointed in you. I'm not even disappointed in your teacher. I'm just disappointed in the scenario where I'm teaching you guys Algebra 2 without you guys knowing all the things from Algebra 1. You thought it was the box thing. What are you talking about, the box thing? I'm not even sure what you're talking about. I only have 15 minutes, and I really want to get through the quadratic equation. So, take a picture of this now. Alright, you guys done? Okay. So what I'm going to do now is I'm going to do this thing called the quadratic equation. All right? The quadratic equation. I want you to write this down. Or at least don't write this down, because every single step that I do is already on that little piece of paper that I have right in front of you guys. I'm showing it to you. It's right by this red dot over here. I'm doing all of these steps. But what I want you to do is fill in the equivalent of those gray boxes. Fill in the why I'm doing this. What am I doing? All right? All right. So, wait a second. Why the heck are they doing that? That doesn't make any sense. All right, forget it. Don't do what they're doing. Do what I'm doing. What they're doing doesn't make sense. Let's do this one together. Ax squared plus bx plus c equals 0. When I show this to you, and actually if you really think about it, and I can see the equivalent of it, I can see why they did those things, but I feel like I can teach you better if I just show it to you like this. All right. The first rule of the completing the square is I don't like a number over here. I like to have my x squared term have nothing on it. If you look on that original equation we did over here, it had nothing on it, so we didn't worry about that to begin with. But for now, what I need to do is I need to divide by a. So I have x squared plus b over ax plus c over a equals 0. Good? All right. Now what I'm going to do, all right, write down exactly what I write down, and write down the explanation. And you know what? Go back and re-watch this video so that you can write down the explanation. Let me just tell my wife that I can't talk to her. Actually, hold on. This is a... Hello? Hey, I'm actually teaching right now. Can I call you back? Okay. All right. So, what I'm going to do now is I'm going to do that crazy trick where I have x squared plus b over ax. This time I'm going to add b squared over 4a squared. Okay, write this line down. I'll explain to you why I did it and what I did. Why I did it and what I did was I took this b over 2a or a b over a, I divided it by 2, and I squared that whole thing. So b over a becomes b over 2a. When you square that, that becomes b squared over 4a squared. That's why I added this. Does that make sense to you? It's the same exact thing that I did right here. I took this number that had the x in front of it, I divided by 2, and I squared it. I did the same thing there. It's just I'm doing this with letters, so it looks a little bit more confusing. Hang in there. Hang in there. Be strong on this one, all right? All right, so now what I'm going to do is I'm going to take these first 3 terms and deal with that. This right here is x plus b over 2a squared. That's what those two things are equal to. If you don't believe me, do this at home. X plus b over 2a times x plus b over 2a. Foil that out and make sure that I'm not spouting off crazy stuff. Foil this out and make sure it's equal to that. Alright? By the way, is the video frozen? I need everyone to answer me because I want to make sure that I'm good. I need to start up the next class, and I only have 5 minutes to finish this. Alright. I'm going to take this over to the other side, so this is equal to b squared over 4a squared minus c over a. The reason why I switched the sign is because I threw it onto the right side. I'm going to combine these fractions. X plus b over 2a squared equals b squared over, all right, minus 4ac all over 4a squared. All I did was I made these, this is an a but not a 9 by the way. I made these fractions the same by multiplying the top and bottom of that right one by 4a. Now what I'm going to do is I'm going to take the square root of both sides. X plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. And then the last thing I'm going to do is take that b over 2a and put them on the right side. So I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, I know what you're asking. You're asking yourselves, wait a second, is he expecting us to do this kind of math on our homework? And the answer is no. I'm just showing you where an equation comes from. I'm just showing you where this thing comes from, so you know that I didn't pull it out of my butt and throw it up on the board and say, memorize this for the rest of your life. I'm showing you that it's not magic. That all I'm doing is following all of the rules of mathematics. Not even that complicated rules, just a little weird, not even a weird, just a little weird trick that I picked up. But I'm still following the rules of mathematics. And I'm going to give you a gift here. At the end, in fact, here's the gift. I'll show it to you already. Those are over the same denominator, right? So if they're over the same denominator, I can just combine them. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. This, my friends, is called the quadratic equation. All the quadratic equation does is it helps us solve very quickly these kinds of problems. Now, I guess I'll have to cover the rest of this on Monday because I'm totally out of time. But write this down and know that it's not magic. I've proven to you the quadratic equation. That was my feat for today. I know that you must have a lot of questions. I apologize that I can't answer them. Have a wonderful day. I will answer them on Monday, I promise. Okay, bye. I'm sorry I have to leave class so quickly as well. I am starting another class in 5 minutes.